Hey, hello. Thanks for joining this session. This talk is Street Cred. We are talking today about increasing trust in passwordless authentication. My name is Wolfgang Goerlich. I'm an advisory CISO with Duo Security, now part of Cisco. And with me today is Chris.
Yeah, and hey everyone, I'm Chris Demundo. I'm a product manager in our authentication team here at Duo, responsible for our passwordless initiatives.
And so Duo, of course, is the secure access company, and we have been looking at passwordless and overall trust for quite some time. But I want to take you back well before there's Duo, well before there's Cisco, back to this guy. Those of you with about as much gray in my beard and your hair may remember this. This is the 7094, the IBM 7094. Now, there's two things about this piece of machinery I want to tell you about. One is if you're into sci-fi, right, you've probably seen 2001 Space Odyssey. If you've seen 2001 Space Odyssey, you probably remember that scene at the end where Hal is slowly fading away, right, singing Daisy. That came from this machine. That came from Arthur C. Clarke singing the IBM 7094, sing Daisy, Daisy, and that led him to believe that by 2001, we would have human-level intelligence in machines. Really cool piece of history. The other thing that started at this point in time was passwords. MIT, 1950s, had one of these machines. The first passwords were rolled out. Of course, they're clear text. That means the first password breach happened on this machine when those clear text passwords were mixed up with the message of the day file. Accidentally, I'm sure. And that led to a Friday in 1957 where they're like, we must fix this. We will implement encryption. And since then, for 60 years, we have effectively had two things we could do to protect authentication, to protect this first and oftentimes, unfortunately, last factor of security. What are those two things? Well, one is the machine, right? We're going to encrypt the password. Now people are going to try and steal those files. We're going to better protect those files. We're going to use better algorithms because they're trying to brute force it. Now people are going ahead and creating rainbow tables. Okay, fine, we'll include a hash. We've had this step-by-step growth on the machine side. At the same time, we went to the people, right? We've said, all right, I need you to remember longer passwords. I need you to remember more passwords, unique passwords. I need you to change your password every 90 days. And by the way, we're just going to keep adding systems that you got to log into. Since the IBM 7094, since the 1950s, those are the two things that we've been able to do. Ask more of the people or ask more of the machines.
Yeah, and it really is two things, Wolf, because we've really offloaded the risk that's inherent to passwords as just additional actions or steps, or as you talked about, complexity that we expect the end user to take. And so getting rid of passwords is about two things. It's not just about the security associated with it, but it's also about usability. Every conversation I have with someone at the CISO level revolves around usability. It's like, yes, I get that this improves security. That's an obvious, but I also think about it as a way to improve the end user experience. I can't tell you the number of your peers that have told me, like, I moved this to a 16-character password last year, and people still won't let me live it down.
So we need it to be usable clearly, but we also need to then rely more on the machines, to then rely more on the detective and preventative technologies. And that's really the focus for today's agenda. We want to look at a path to passwordless, not because anyone in here doesn't know how to get to passwordless. We all do. But it does provide a good frame for some of the key controls along the way, some of the key ways that we can increase trust in authentication. Things like rules, correlation, policies, certainly. Things like ML, of course, and bringing this all together to form risk-based authentication. That's the agenda for today, and that's what we're going to be digging into.
Yeah, and so we frame this as a path, and we really want to spend this next section kind of talking about how we see companies starting to move towards passwordless and what factors are important to consider when thinking about your passwordless strategy. And so we really see 5 steps in the transition to passwordless. The first is really around ensuring that you have strong multi-factor in place already, and really strategizing and identifying use cases that exist in your environment where you want to start with passwordless, because we know there's a ton of them. The second is really in consolidating authentication workflows. So think about SSO and federation as a way to reduce the number of passwords being typed. The third, and this is really where we're going to focus today, is in increasing trust in authentication, and thinking about that in general, and why that's important as you consider passwordless. And finally, building on those, it's about actually enabling that passwordless experience for your end users and continuing to improve and optimize that over time.
So let's start with that first step. Let's start with good authentication and good factors and really identifying the individual use cases.
Yeah, and so there's a lot of factors that are probably in play in your environment today, depending on the business use case or user demands that exist in given cases. And so adding MFA on top of passwords is something that we've traditionally done to offset the weakness in passwords, and that can take a lot of forms. But if you think about the problem that passwordless aims to solve, it's increasing security while also making the user experience better. It goes back to as I talked to a couple minutes ago. And so one way to think about passwordless is obviously, well, let's just remove the password and then authenticate with some other factors. And that really might not be the best way to approach it, because first of all, if you use factors that have their own security problems, think about just saying, hey, let's let users authenticate with an SMS code. You might just be recreating issues in the security realm. But if you think about stacking multiple factors on top of each other in order to increase security, well, then you're back in the same boat that you're in with MFA, and you're not solving for the user experience problem. And so thinking about your use cases and what factors are appropriate and where you can start moving to strong factors like FIDO2 that combine multiple factors in one step is a critical first step on the path to passwordless.
And another step along that way, when we talk about trust, is making sure that there are not scenarios where attackers can downshift, right? All right, we're in a passwordless environment because I don't have to put in my password as a user. Awesome. But does that password still exist? Can a criminal still enter it either directly or in a side system? Clearly a problem. The other problem is that what happens if we're doing device recovery? What happens if we're doing enrollment? Those key points where we need to establish and bootstrap trust. We need to make sure that we're not saying, all right, all these rely on a 4-digit PIN, all right, or all these rely on a easy to guess instrument. So the downshifting aspect is critical when we start looking at the different use cases and figuring out from a threat scenario perspective what ways the adversaries might work around these stronger factors. The next step is bringing our authentication workflows together. There's a lot of them, right? we can immediately reduce some of the passwords that users have, hopefully, thankfully. But studies show that a typical person in the workforce has 191 passwords. There's a significant number of systems that we need to get our hands on and start bringing those down. Because 191 passwords for people to remember, choose complex ones, do those things is a significant amount of work. But B, from the machine perspective, right? If we're managing policy and control at 191 different points, that's a lot of management oversight. That's not a lot of work. And that's a significant gap that criminals are going to be probing and looking for areas where the policies don't match up. So we think about how the adversaries may work around this. As we put in stronger factors, what are they going to do? They're going to downshift. We already talked about that. They're going to look for legacy systems, basic auth that may still be enabled, old systems that are still accessible, that credentials can be replayed against, brute force attacks can be happening, that can be leveraged for credential stuffing. They're also going to be looking for any unprotected systems. Our developers are still building. Awesome. Are they making sure that this is integrated with the rest of our authentication workflows? And finally, any unknown apps, any gaps in our visibility across the entire application portfolio.
Yeah, and because if you think about it, in a typical enterprise environment where end users are now using a mix of cloud and internal apps, where new applications are getting added all the time, a typical enterprise has over 1,400 applications that they have to manage and think about. And so, federation isn't really a new thing, obviously. Many of the organizations that I've spoke to have been thinking about a journey to consolidate authentication workflows for quite a while now. And again, I think of it as a spectrum with some companies on one end and some companies further on the other end. One tech company that I spoke with recently was really far along on that spectrum. And over the past few years, they've really focused on establishing processes for how they onboard new applications and for new application owners to get their applications federated in a standardized way. And at this point, they've actually been able to implement policy where if a new application doesn't support SAML or OIDC, they're not going to support it as an IT organization. And as a result of all of this effort, they've estimated that about 90% of their applications are actually covered by federation at this point. But it doesn't stop there. I was talking to the admin responsible for their infrastructure, and he told me like, okay, we've gotten to this point, but now I have users starting to come up saying like, hey, I can use Face ID to log into my bank application. Why can't I use that to get into my work applications? And so now he's thinking about, okay, what's the next step? How do I continue to improve the user experience while increasing or maintaining security along the way?
And I like that 90% number too, because oftentimes we're looking at our environments and we're like, oh, wait, we've got 1,400 apps. How many do you have secured? 10, maybe 100, right? The idea of having 90% coverage is incredibly ambitious. And again, reduces all those gaps, those holes in the fence that we are constructing. So those are some of the early steps we can do to increase trust and authentication before we even get to some of the more robust ways we can do it. And when we think about robust way, there's two ways I want to slice this. One is the traditional set of controls, right? The things we know are bad. If you're in Amazon, you can put stuff in the shopping cart all day long, but the minute you try and ship it to someone else's address or change a credit card, they're going to cause you to log out, right? That's a known bad thing. That's a known indicator of fraud, right? So we can build rules around that. By contrast, credit card fraud, which is heavily involved with data science, heavily involved with machine learning, they're always looking for patterns, right? You can't necessarily make a very simple rule to catch that. So these are the two main ways that we want to act when we talk about reducing risk and increasing trust and auth.
Yeah, and so when we think about kind of the ways that you can look at rules in your environment, one of the natural things to look at is thinking about devices and what devices are accessing applications. And in many cases, you have an existing solution in your environment to already identify known devices, an MDM solution, for example. And the hard problem really becomes, how do you leverage that information at authentication time to help make decisions about access? And so there's many ways to do this, right? Duo, for example, can help you take a cert-based approach where you can use your MDM to distribute certs out to known machines that we can check for at auth time where we're involved. We also leverage an agent-based approach where certs are inappropriate, leveraging our mobile application for companies that don't have an MDM in place or just prefer not to use certs. But the important part is really here, you can generate a signal around known risky areas so you can bind users to known devices and help minimize risk when it comes to identifying what devices are being used to access critical applications in your environment.
And just a couple of hours before giving this talk, I was actually having a conversation with someone who was doing the device identity, right? They said, you can only enroll multi-factor on our known devices. Great, awesome. But what ended up happening was there was actually a vulnerability in one of the devices that drive-by malware executed on. So now the adversary was on that device and was able to then enroll their own device for multi-factor on the person's computer. A little bit more of an advanced attack, but definitely something we want to be aware of. The security posture, which I would say is like the status of the machine, its overall hygiene, and then the state, is it infected or jailbroken, those sort of things have to be considered as well, because these are vectors that criminals are going to use if they can't get on with traditional password attacks.
Yeah, and I work with companies often that know this, Wolf, and they have security goals around things like maintaining up-to-date OS versions. And they really find the difficulty is in visibility that the posture is maintained at the point of access. I was working with one tech company that started tackling this problem at the endpoint level, so working on shoring up their processes around patching and updating. But then when they started testing Duo at the point of access, they found they still had things like contractors coming in on outdated OS versions that they didn't have direct control over. And so the hard person for them really was ensuring that they had visibility in the moment without significantly creating blockers or increasing user friction that stopped people from working.
Hmm. So detect the things, don't necessarily create friction, but also then, of course, collaborate with the folks to go ahead and remediate. The second way is, all right, so now we've sort of filtered out a lot of things we know are bad. All right, jailbroken device, an infected device, contractors coming in with unpatched devices. There's still a lot of things that we want to consider. There's still a lot of different areas that we need to probe. And this is where I believe that machine language, good algorithms, good data science can play strongly. And we've seen some great improvements in machine learning. We've seen some great improvements in the use cases, right? So you can go to Google and you can type something like cake and get a whole bunch of cakes. Awesome. For that to work, we need a couple things. We need a well-defined problem. We need a lot of training data. Give me tons of pictures of cakes so that I can recognize a cake standing alone, or I can recognize someone having a birthday cake. Lots of training data. And then the last thing is it needs to be in a situation that's good enough. So I see this and I can very readily go as a person, you know what? Sushi, that picture of sushi right there, that's not cake. that is a lie. That is not cake. And I cannot select that without having much of a cost. Additionally, I can have some internal debate or talk amongst my friends. Hey, a cupcake, is that really considered cake? Maybe it is, maybe it isn't. But that decision-making process is mine and mine alone, and the decision-making cost is relatively low. And those are areas where we see AI ML working very well. And of course, this can be a problem because a sufficiently successful attacker is oftentimes indistinguishable from a user. Remember, at this point in time, they've got creds, they've been able to get through multi-factor, they're on the user's device, or have somehow mimicked the device authentication. And that is a really hard thing to see for a number of reasons.
Yeah, and so if you think about it, right, like if we go back to kind of our rules-based approach we talked about earlier, as an IT administrator, you might have a lot of experience and know what things look suspicious and should be flagged for or disallowed. But it's a really difficult proposition, right? Like authentication behaviors evolve, threats evolve, risk is dynamic. It really requires a deep understanding and expertise of the data, and the complexity grows really quickly. And so as you point out, Wolf, like ML offers a potential solution here. Like it's obviously really good at identifying patterns in large data sets. But even in this case, think about the thing that we're trying to predict. It's hard. Attacks are infrequent and they often mimic normal behavior when they're well targeted. False positives are also really expensive. It's not like the cake example. Admins don't have time to spend running down hundreds of false positives to find an attack. So even in the domain of machine learning and data science, this is still really a hard problem to solve.
And we've got a lot of stats and a lot of visibility now into that last thing you said, Chris, which is admins don't have time to run these things down. Having built SOCs before, having built SIMs before, having stood up managed services, we see again and again and again, man, alerts are costly. There's way too many of them. Alert fatigue is a real thing. It's only gotten worse. This data is from a study that Cisco did, the CISO benchmark. And, a majority of orgs, 2/3 of orgs are seeing up to 10,000 alerts. So adding more noise from our authentication system to that is not a good mix. It's costly and it creates a lot of confusion. Moreover, we might say, okay, that's cool. That's a cool story. No problem. We'll just say when we see cake, block. But what happens if it's sushi? What happens if it is a cupcake? And that cupcake just happens to be your executive behaving in an unusual way. We don't want to create a situation where we've got denial of service by CISO, right? We don't want the security team and the policy to be stopping the organization from working, especially when our stated goal is to protect the organization and the organization's ability to get work done, which is why policy is so hard, which is why modeling these things is so difficult, and why the cost of false positives is so high.
And this is something that we've actually been exposed to, and we've been iterating on at Duo as we've rolled out our behavioral analytics solution over the last year. We originally focused on tackling kind of this problem by baselining individual user behavior. So your example you gave, Wolf, of is the CEO acting abnormally compared to her previous behavior from what we've seen, and we found in beta testing our solution with customers that this approach generated still a lot of events, too many for admins to handle easily. And so as we really thought about the problem more broadly, like the breadth of our data really adds value here. So Duo sees over 800 million auths every month across thousands of customers. And so we're shifting to a new algorithmic approach that internally we've called Occam, which I love the name, credit to the engineering team for that, that really looks to infer context from the company as part of the risk application. So we're in the process of deploying a model that can help answer, compared to employees that are similar to you or similar to any given employee, is the action of one employee abnormal on any given day? And we found this approach to be really successful. Like adding context around it has significantly reduced the false positive rate and continues to allow us to highlight abnormal behaviors for admins to be able to look at. And so this is an area we expect to keep learning from and iterating on as we go forward, kind of leveraging that context we have both within customers and across our customer base.
So when we start bringing all this together, we need to start with good platforms, right? Smarter platforms, which is going to come out with partnerships with Apple, Google, Microsoft, the good biometrics. Why? Because when we think about trust starts bare middle, right? Trust starts at the beginning, and being able to validate trust as close to the metal as possible is critical when we start thinking about biometrics and using that device authentication using that device as a FIDO token. So we start with smarter platforms, and then we enable device trust with device authentication and a bunch of known checks to make sure that we're not with a access device or an authenticating device that's infected or has been tampered with or could be compromised. And that rules out a lot of problems. That makes a lot of hurdles for the criminals to jump over, but we know they will, right? The minute everything gets secure, it's not like everyone's going to go give up their day job and go work somewhere else. We can then reduce some of that residual risk with data analytics, evolving these algorithms like Occam, where we're pulling in a big data set and we're looking for those abnormal patterns and surfacing those. And all this comes together with some adaptive policies so that when we do have really clear signal, when we do absolutely know that this is verboten, we can act on it without having to surface that up to our SOC team.
And so really our goal here has been to lay out a path of stepping stones on the way to providing trust. And the first step, of course, is the need for strong non-password based factors. But on top of that, we layer trust at the device level. So being able to define if a device is known or unknown and make decisions based upon that and also the health of the device. And on top of all of that, layering on intelligence at the time of authentication to evaluate the contextual information around the authentication as an additional level of trust. I spoke with a CISO who really articulated this well. When I asked him what passwordless was for him, he said it was two things. The first is a way to reduce user friction, but the second is a way to confound attackers. He said, if you look at things like strong factors, certs, device registration, network posture, and evaluating it all at auth time to see if it looks normal, it makes it really difficult for the attacker to know how to be someone, how to act like an insider.
So now we've got just a few minutes left at this point in the journey. We've got some, base level of trust and authentication that allows us to do some experimenting with factors, right? It allows us to try different use cases, allows us to try different parameters and sequences, allows us to do these things without causing inherent risk. And really at this point in time, I think about it in terms of puzzle pieces, right? Take a use case off, snap it in, make sure it works into this overall framework. And if it doesn't, let's roll back and have the ability to adjust and try again.
Yeah, and I was talking to a hospital system about exactly that, Wolf, and their efforts to go passwordless. And, they told me they really think about it as how will we go passwordless over the next 5 years? Like we can start right now, But we have hundreds of applications covering federated apps, direct AD login, RDP, passwords at the OS level, and myriad other use cases with a really complex environment with corporate users and clinicians. And so the admin I was speaking to really told me, I think about it as the more passwordless I can incrementally do starting now, the better off we are in the long term.
But when we think about incremental, one thing we do need to keep an eye on is optimization, right? We don't want a bunch of point solutions. We don't want a bunch of tools. Again, lots of data shows that even though you think, hey, I got more tools, I got more vendors, I'm more secure. The data, of course, doesn't back that up. Again, to the CISO benchmark study, we see the more tools you have, the longer your downtime is, the longer problems persist. So in optimization, we want to make things as smooth as possible as we bring all these pieces together and as we really lay the foundation for working with stronger factors above and beyond the password. So this was the journey we walked through today, right? Starting off with the factors and the use cases, consolidating those authentication workflows, and looking for opportunities to have fewer passwords, less passwords, as opposed to passwordless. And then really doing the deep dive on trust and how we can establish trust, and how that trust allows us to do different experiments in authentication.
But when we think about it, Wolf, when we're discussing increasing trust for passwordless, it's really part of a much broader conversation on zero trust in general. And it doesn't really only come down to the technology. We can kind of go back to the human stories at the top of the talk. It's also about the human solution that really forms trust, making systems easier to use and actually align with human behavior, not offloading risk from our system onto like additional things that we want our users to do, is a critical step for both passwordless and zero trust in general. And so when we talk about this internally, and this is from one of the product designers on my team who just recently had a son, we think about the future generation of potential authenticating users and hope that they never have to actually know the PIN of a password, and that authenticating is just easy for them.
I love that. And we think about the past 60 years and what it's keyed up and what it's taught us. And we can then look forward to the next 60 years. And again, reduce that burden on the human while improving the overall risk posture by increasing the burden on the machine. So what to do next? Well, obviously include passwordless in your short-term and long-term plans. I don't think you'd be at this conference if you weren't already doing that. The other thing is, putting on my CISO hat for just a minute, tying those strong authentication to broader initiatives. We're going to be reducing the friction on the users. What at that same time can we do to improve the overall security? A lot of it is around zero trust and around these concepts we talked today. But I look at orgs that are using passwordless strategically, and the thing they all have in common is this is the benefit they bring to the user, and at the same time, this is what they're going to ask from the organization to increase the posture. So make sure you're tying it, make sure you're bundling it, and then take steps to increase authentication as we talked here. Rules-based, obviously, risk-based, definitely. The application of machine learning as a tool to reduce residual risk. And that's it. Thank you very much for joining the session. Of course, feel free to come out and join us at the Duo booth. And thank you to Authenticate for having us on today.